Léguas.
It ultimately lost against Microsoft Windows, but OS2 had some neat and sometimes underrated features, one of which I'm going to look into today. The OS2 Virtual DOS machine, which was unique for its time and a perfect proof for IBM's claim that OS2 indeed was a better DOS than DOS. Retrocomputing is the use of older computer hardware and software in modern times. I'm the vintage collector and these are my stories. Even with the very early versions of OS2, which were under joint development between IBM and Microsoft, the operating system already had the ability to run DOS applications. Initially, this was limited to a single full-screen DOS session, as the then current 8286 CPU didn't support yet the virtual 8086 mode. This was also the reason that the DOS support in OS2 initially was plagued by compatibility and stability issues. This was only going to change when OS2 2.x came along. Rewritten from scratch and transitioning to a true 32-bit implementation, OS2 2.0 embraced the 8386 processor and its capability for the virtual 8086 mode. OS2 thus finally gained the ability to run multiple concurrent DOS sessions by means of the MVDM feature, the Multiple Virtual DOS Machines. And this new MVDM was without a doubt so advanced and powerful, making IBM's promise on OS2 being a better DOS than DOS a sheer understatement. So while I was configuring this high-screen Killarney Tower for a true DOS Windows OS2 multi-boot setup earlier on, I decided to have a deeper look into OS2 Warp's MVDM feature. And after creating a bunch of boot disks, I was reading up in the user's manual, although I somewhat felt it told me only halfway the story. Well, in its most simplistic form, you simply insert a boot floppy and fire up an MVDM using the DOS from Drive A icon. At first I thought something went wrong, as it took almost an entire minute until the install screen of MS-DOS 4 came up. Not all versions of DOS I went to try expose this behavior, but generally booting DOS from Drive A took considerably longer than expected. To exit the VDM is not sufficient to type exit, as this is not just an ordinary shell. You can press Ctrl and Escape to go back to OS2 and close the VDM from the task list. However, there's another, more elegant way how to terminate the VDM, but more on that in a moment. While OS2 already came with its own subset of DOS 5, the DOS from Drive A feature specifically allows you to literally boot into any version of DOS, like here a vanilla MS-DOS 5. It would however complain not finding any hard drive, which totally makes sense at this point, but let's hold that off as well for a moment. Now, you won't be surprised to find that the MVDM also boots into MS-DOS 6, but what about Gary Kildall's DR-DOS? Well, apparently OS2 seems to have no issue with DR-DOS 5 and neither with DR-DOS 6. Even Novell DOS 7, which essentially was DR-DOS 7 just during the era when Novell had acquired Digital Research in order to better compete with Microsoft in the early 90s, works just fine. As Novell DOS 7 was trying to start its setup routine, it would complain about write-access errors on the C drive. And this is yet one more thing to memorize for our later investigation. Because beforehand, I want to check out yet another lesser known DOS, PTS-DOS by Fizteksoft, a Russian company that developed a compatible DOS for the Russian Department of Defense and made it commercially available in 1993. And it too seems to be no big deal for booting under OS2. Now, when booting into Windows 95, aka MS-DOS 7, will get this protection fault, claiming that access to the A20 gate is not possible. One can choose to ignore this and MS-DOS 7 would continue to boot, however noticing yet another thing to follow up on HiMemSys's inability to lock the A20 gate. And the same goes true for Windows 98, otherwise known as MS-DOS 7.1, exposing the same behavior.
What about Windows Me?
MS-DOS 8 from Windows Me seems to be a different beast. It too initially runs into the same issue about the 820 gate, but then comes to a forceful halt.
Why is that?
As noted in my last video about Windows Me and MS-DOS 8, the IO.sys was changed in a way to already include HIMEM.sys and load it by default, essentially not needing it to be configured in config.sys. And that means it can't be bypassed. Now, the 820 gate was introduced with the appearance of the 8286 CPU, which could address up to 16 MB of RAM. The 8086 and 8088 predecessors could only address 1 MB of RAM directly by means of 20 memory address lines referred to as being A0 to A19. And since memory addresses could be constructed in different ways, it could happen that an invalid segment address was created, pointing to a hypothetical memory address above 1 MB. As the 8086 and 8088 didn't have matching address lines, it would result into a wraparound for the memory address, and many old software of the days relied on this exact behavior. Hence, IBM had to introduce a hack when the IBM PC-AT and the 8286 came along, and this was the switchable 820 line. Originally a logic gate tied to the keyboard controller, it was meant to disable the 8286's 820 line in real mode to enforce the memory address wraparound. In protected mode, the 820 line would be enabled to allow memory access above 1 MB. And as such, that functionality was built into memory managers like HIMEM.sys to be gatekeeper for the 820 line. Now, as evidence shows, the MVDM in OS2 is not a real hardware abstracted virtual machine, but only using the CPU's virtual 86 mode. As such, direct control to hardware, as seen in the example of the 820 gate, is not possible, as OS2 still controls that in the background. The guest OS booted via the MVDM will not be given control to 820, which then leads to the observed errors about the inability to control 820. In the case of MS-DOS 8, aka Windows Me, it would ultimately even lead to a segfault, as the OS assumes exclusive control over the hardware. This is very much different to a full hardware abstraction as seen in products like VMware, VirtualBox, Hyper-V, or the then contemporary products like VirtualPC or SoftPC. Still, the MVDM does provide many properties similar to modern day's virtual machines to configure certain aspects as shown here. It's interesting to note that you could configure the amount of XMS and EMS memory available to the DOS VDM even back then already. Not all of those settings would however apply to any arbitrary guest OS booted into the VDM. Most of the properties would be considered only for the DOS-like subsystem that was included with OS2.
But how would you now access the XMS and EMS memory if the HIMEM.sys coming with DOS wouldn't load because of the 820 issue?
A good question, and to answer it, we must first ask ourselves, what does the manual say? And it tells me to copy some files from the C:/OS2/MDOS directory over to the floppy disk, those being fsfilter.sys, fsaccess.exe, ANSI.sys, and, obviously for the memory management, HIMEM.sys and EMM386.sys, and also mouse.com. Then I'm instructed to create a new file via the text file templates and add certain familiar looking config clauses and save it to a:/config.sys. Likewise, I'd also create an autoexec.bat. Let's see what happens if I step through the configuration while booting up MS-DOS 6. Obviously, the trick is to replace DOS's own memory drivers by the ones of OS2 to make the memory accessible within the VDM. And this would then overcome the limitation concerning the 820 line in the original HIMEM.sys driver, as it can be observed here as well when booting off MS-DOS 7 from Windows 95. Now, we've previously seen issue with the hard drives, both with detecting them but also with write access errors. In the example of this instance of OS2 running in VirtualBox, my disk has two partitions, a FAT16 primary partition for MS-DOS and an HPFS extended partition logical drive for OS2. Checking within the DOS VDM, I would only get to see the C drive, which corresponds to the FAT16 MS-DOS partition. While fdisk reports me the existence of an extended partition even within the VDM, I would not get to see the OS2 partition within the DOS session. This would happen only after I add the fsfilter.sys driver to config.sys, which makes the D drive, so the OS2 partition, available to the DOS VDM.
Would it be possible now to delete the disk partitions from within the VDM?
That's indeed a good question. We can try, for example, by rewriting the master boot record. As you see, the system would fail since it couldn't acquire an exclusive lock to the hard drive for overwriting the MBR.
But what about debug.com? It's certainly possible to do a low-level bypass.
Nah, apparently that doesn't work, as I would certainly have expected this to be blocked as well.
Try the non-DOS partition.
As you wish, but that's not going to work either.
Huh! See, it removed it.
That's what you think, but look, it's back again, as it essentially never was removed from within the VDM. They clearly didn't make it as easy as that. It's the same thing as with the A20 gate. There's no direct hardware access, hence certain things simply don't work. Still, with fsfilter loaded, not only the OS2 partition becomes visible to the DOS VDM, but also the disk write errors are now essentially gone, so at least it's possible to copy files across the two disk partitions without triggering any further disk I/O errors. Having said that, it's about time to see how to properly exit the DOS VDM, as it's certainly cumbersome to always go to the task list and kill the session from there. Again, you need a command file from OS2's mdos directory, which is the exit_vdm.com file. If you make that available within your DOS VDM, you can simply type exit_vdm to quit the session. It's as easy as that. Up and until now I was always using boot floppies to start the DOS VDM, but actually that's not necessary. Here's again the partition setup of my current VirtualBox VM, exposing the primary DOS partition and the extended OS2 partition for a true multi-boot environment. Now, it's perfectly possible to tell OS2 to start a DOS VDM off the primary DOS partition instead. So I'll quickly make a copy of the DOS from Drive A launcher, then edit the program icon to show it's booting off Drive C. But what really makes it work is the advanced DOS settings, where you change the boot drive from A: to C:, and voila. So it's actually very easy to share the native DOS on the primary partition even inside OS2 with a DOS VDM if you have exactly this partition layout as shown. I couldn't demo this on my real machine, as there I chose a different partition layout, where in fact both DOS and OS2 were installed to two different primary partitions. And as a fact, only one primary partition can be active at a time, essentially hiding the other one, thus making it impossible to share the C drive in this case. Anyways, booting DOS off the C drive already accelerates the startup time by orders of magnitude. But there's yet one more method how to boot off a generic DOS into the DOS VDM, which involves disk image files. The bad thing is that the user's manual doesn't really explain this, but when digging into the DOS VDM settings, especially the startup drive option, you get a hint, as it mentions disk images created by VMDisk. Checking through the OS2 online help, I didn't find anything at first, but eventually calling up help vmdisk from the command line did the trick. So it seems to be as simple as running vmdisk and providing it the source drive, A:, in this case, and the destination file ms.6.vmd in my example. And coming from here, simply point the startup drive now to the captured disk image file as seen here, c:/os2/mdos/ms.6.vmd. And voila, DOS is now booting off the disk image file, although that still claims drive A, and it's in fact a lot quicker than booting off the real floppy disk. However, the use of a disk image file brings another problem, because how to now access a real floppy disk? So I've been copying the fsaccess.exe onto this boot disk before, so it's now as well inside the disk image file. fsaccess allows to unmap the drives claimed by a disk image file from within the DOS VDM. Running fsaccess shows which drives are currently available. As drive A is still the current drive, it can't be unmapped. But when I change to drive C and run fsaccess again, drive A will be unmapped. The error here about failing to load command.com was to be expected, as I unloaded the disk image file from drive A. So when I swapped in the real boot floppy disk, command.com would now load from the physical floppy disk instead. In my last video on MS-DOS and OS2, I've also shown how I shared Windows 3.11 between the two. Maybe it's also interesting to see that when properly configured, it's possible to load a custom DOS version into the DOS VDM, like here Novell DOS 7, and have it run the locally installed Windows 3.11. Windows will actually run as an instance of so-called WinOS 2, however it would inherit the DOS VDM session settings. A good example to show this is in the info dialog, where we see the minimum amount of RAM available to this DOS VDM being reflected into Windows 3.11. Compare that to this one here, the real WinOS 2 has launched directly from the OS2 Workplace shell, exposing an overall of 64 MB of RAM. And using Z technique, it's perfectly possible to start MS-DOS 7, aka Windows 95, and at least run Windows 3.11 on top of it.
But you claim to run Windows 95 from within OS2. The real deal. Come on, you lied. It doesn't work. Look here. Click beta.
True. OS2 can't run Windows 9X inside the MVDM. If it were possible, people had done so a long time ago. There is, however, one feature that OS2 Warp 4.0 brought along, which is called Trapdoor. Trapdoor adds some level of integration between Windows 95 and OS2 and will be subject of the next episode. In the meantime, there's still one more thing. I wonder how far I can push OS2. The manual states that the DOS from Drive A feature can boot any DOS greater than 3.0. Now, I wonder if that is really true. What about a test write with PC-DOS 1.0?
I wonder what useful purpose would that be for?
See, it boots, although for reasons unknown to me with a blue screen distortion. But anyway, it seems to somewhat run.
And what next? Will you now pull out CP/M from the head?
You bet. Here's CP/M 86 1.1 for the IBM PC. And I also tried concurrent DOS, and while the first seems to at least do something before locking up, the latter wouldn't even go past the blinking cursor. Still, nothing could show better how close DOS and CP/M in fact were, and how good both Intel's Virtual86 mode and also OS2's MVDM was, that it could even boot CP/M, although admittedly, during the 90s probably no one would bother anymore about CP/M. Or what do you think about it? Let me know in the comments below. I'm the Vintage Collector, and this was my story for today. Thanks for watching, and see you again next Sunday. Next time on The Vintage Collector. So Windows 95 can't run natively on OS 2 no matter what. However, the trapdoor feature found in Warp 4.0 is said to add some level of seamless integration, at least in theory, had it not failed on me.